Hello.
Hello.
Hi, how are you?
Hello,
I'm good. How are you?
All right. Vidhi and
I
Akshat.
sent you Slack. Did
Oh,
you check the private chat on Slack? I've sent you something.
yeah, I saw that.
Okay.
Yeah, it was that proposal, so I'll look it over.
Okay.
Is that something you wanted to present on today, or I'll give you some time for
No,
that?
I don't want to present it. I'm not going to be presenting it today because it's not yet ready. That's just my idea of it. I'm probably going to add more, but I wanted to know your thoughts on it. Like, is it good? And
I mean, yeah, I'll look it over. We'll see.
okay, 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 okay.
All right. So why don't we get started? Welcome. This week we had one meeting. We had DevoWorm, and we've been working on some things kind of behind the scenes, and so those will be coming out soon. We're getting ready for Embodied Intelligence Workshop. That is on March 19th and 20th. So I'm going to send out a link in the Slack channel to let everyone know where to find it if you'd like to attend, or I think they'll be recording it. There'll be recordings afterwards. I'm presenting some things from the lab's work. Jesse is, I think, also presenting. He mentioned something in the Slack about some presentation he wanted to do, and it looks good. So we'll see. And that's great. That looks like it's going to be an interesting conference. The way they're organizing it this year is they're going to have like 3 time zone tiers. They're going to have Asia, which is for like Japan and China and Korea, centered on those time zones. Europe, which is like the European time zones, and then uh, the Eastern time zone of North America. So all the time zones there. So it's like people can pick the one they're closest to, and be kind of, you don't have to be awake at 3 in the morning because it's a virtual conference. And so, yeah, I will. I'm not. I don't have anything to present today on that, but that is coming up. Then we have some other things coming up, some other deadlines, and I will be communicating those internally as they become we get closer to them. So one of those, of course, is Google Summer of Code, and the deadline for proposals there is March 31st. So if you are looking to submit a proposal for Google Summer of Code, so we have 3 projects. One is the DevoWorm project, which is DevoGraph, and that's the project where people are proposing various techniques related to graph neural networks. So we've been focusing on graph neural networks, but we have a longer history in DevoWorm of working with graph structures and networks. And so we have some people interested in that. We also have 2 projects in the orthogonal web proper. One of those is, well, they're both related to open source sustainability. One of those is open source sustainability with kind of a focus on reinforcement learning and other methods like that. And then the second one is focused on large language models. So we actually have 2 projects to apply for. So I don't know how many slots we're going to get. In years past, we've gotten as few as 2, as many as like 7, which is like unusual. But that was one year where we got everyone that applied. But that's not going to happen this year, I'm pretty sure. And so that will be, we'll be getting those applications in by the 31st. That's a Google deadline. And then we will make decisions from there. We'll evaluate the proposals. And so then I think we announce people in, I think, at the end of April or the beginning of May. The timeline is a little shorter than it usually is because we I don't know what the problem or what their procedure is this year, but it's different. And so we don't have as much time to a little bit less time to submit stuff. And so, yeah, if you're applying to the open source sustainability project, either apply to the reinforcement learning one or the large language models learning one. Just find usually if you go to usually there is a discourse through INCF, and they have the projects numbered. And I don't know what the numbers are this year for each one, but it's 2 different descriptions, so just be sure to note which one it is. I mean, we can kind of figure it out because we just read the content and we'll put it in that bin, but just to be clear, just make sure you're targeting the right project. Okay, Akshat, you had a question.
Yeah, I had this question that GSOC allows 3 proposal forms to be submitted for one applicant, right?
Yeah.
So does INCF have an internal limit that one person can only have 2 forms or something like that? INCF and OR.
I think probably 2, yeah. I don't remember what their rules are this year, at least.
Oh.
In the past, I know people applied to like 2 projects or multiple projects. One of the issues with that, of course, is that you have to sort of, get the best proposal you can. Yeah. So, I mean, there are all sorts of ways that people have done that in the past. I would, yeah, but I think the limit is like 2 or 3. I don't know. You'd have to check. Be sure to check the rules.
Yeah, the rules didn't state anything. I tried reaching them by email, but they didn't respond.
Oh, okay. Well, I don't know.
So some time ago, the rule was there is no internal limit as such. There used to be a form that you submit to INCF when you are submitting your proposal, and in that form you would have to mention which other projects have also applied for. So even if they are within INCF, you specify, and even if they are outside, you specify. Yeah, I don't think there is, as far as I'm aware, I don't think there's any limit as such. You just have to declare in that form which are the proposals you are submitting. Because if it's within INCF, of course, we don't want. We want to be able to allocate projects properly. So that.
Yeah.
Okay. Okay, thanks for clarifying it. I appreciate it a lot.
Yeah. So, in terms of the proposals, a little bit of advice on how to write them. I've been a mentor for probably, I think, 9 years. This is my 9th year as a mentor and for a GSOC. And it's been pretty good. We've had a lot of people come and go, and they've put a lot of really good code into our organizations. So one of the things that successful people do is that they, one of the things our organization does, it's kind of different from a lot of other organizations, is that they, you can address a problem in your own way, more so than like a lot of organizations will kind of have a very tightly defined project and then you contribute to that. And a lot of the things that we have, our project calls are very broad, and it says, this is the problem, figure out some sort of solution to the problem. It could be a wide range of solutions. And that's something that you would then have the freedom to propose a solution to. Now, one of the benefits of that is you can do exactly what you want, or at least within the project. The downside is you have to know kind of what works and what doesn't. And this is why we have like interactions before the proposal period, because then you can get feedback on things and try things out and see if it works, see if it doesn't work, etc. And so if we do that, we can get a pretty well-tuned project going in. So when you write your proposal, you want to summarize your approach, sort of in the introductory paragraph. Maybe say why you're interested in the project. what you hope to accomplish with the project, and then you proceed to talk about your approach. What does it involve? Does it involve different types of methodologies, different types of data sets that you might need to get access to? What is the problem statement? How would you address it? What's the scope of the project? And that's important because the scope of the project is going to determine whether you can get it done in the amount of time we have. So we have like 10 weeks where you have realistically 8 or 9 to do something and get it, enough so that you get results and that you can submit it to Google. So, I don't know what that kind of scope looks like for everyone's project. I would just think about a weekly kind of account of what you would do. So you'd want to start. So the first couple weeks of the program is the community period, which is where we usually spend time getting to know the community, getting used to things, setting things up, like maybe setting up programming environments or things like that. Now we take the community period somewhat seriously in our organization. We try to help people make connections or just basically get to a better understanding of what's going on. Our projects are research oriented, so you have to understand the research a little bit, that sort of thing. So after that, then you have your weekly account of, I'm going to hit the ground running with setting up my environment. I might test 2 or 3 models, and I can work from there and try to get a result by the end. And then the last week is usually like finishing up, writing up your proposal submission, doing documentation, things like that. So that's kind of how this is going to look. And then the last part of the proposal is going to be the schedule. So they always want to have, and I think it's good to have, sort of an enumerated schedule where you have an account of every week. So you say week 1, week 2, week 3, etc. And then in that table after the week, you'd say what you would do or what you plan to do for that week. And then you also want to have some account of what happens if you can't do something. Do you have second or third priority things you could shift to while you kind of figure out that bigger problem? So if you hit a roadblock, how do you get around it? Better yet, how would you say if you had a problem with your project, implementing your project, how would you kind of recover from that and do something different? How would you change direction? How would you rescope your project if the scope is a little bit big? Because the idea of Google Summer of Code is not to have everything perfect and then just kind of blast through the project. The idea is that you struggle with implementing the project and everything, and you don't want to have a proposal where you say, well, I'll figure everything out during the project period. But what you want to do is you want to have a pretty good idea of how things will work. And then you need to work through the project. And when working through the project, you're going to hit roadblocks. You're going to be challenged with things, and you're going to have to find a way around them and something that works. And so that's what you need to do. Sort of introduce your problem, talk about how you'll solve your problem, and a schedule. Okay, so that's a little bit about GSOC. And again, those proposals are due March 31st. And try to, communicate with us in the Slack or on GitHub. And I've been really impressed with GitHub communication this year and pull requests. We got a lot of pull requests this year. And I'm going to go through that in a minute. So, yeah, thanks to everyone who's contributed on GitHub. We've had a lot of not just pull requests, but like people helping each other out or talking through problems. And a lot of that has been in the large language models, open source sustainability, or open source community part of the repository. So we have the repository for GSOC, and then within that we have our different, mostly that's like the open source sustainability project. So we have different versions of things like reinforcement learning and large language models and active inference. And most of that has been in the large language models area. But anyways, thank you for your contributions there. So this is our organizational GitHub. And if you've been contributing to the projects, you see that there's this GSOC repository. So this is for the open source sustainability projects. If you're trying to contribute to DevoGraph, we have a separate DevoLearn organization where there's a DevoGraph repository there, and that's where you would do pull requests and look at the open issues. This is our repository. This project goes back to 2022. So in 2022, we did a first season of this where we had people working on reinforcement learning, active inference, and some other types of simulation, sort of a survey of what we could do to address this problem. Then in 2023 and 2024, we worked on some of the models. So we worked on reinforcement learning in 2023. Then we did some large language modeling in 2024. Then back in 2025, Vidhi was the person working on reinforcement learning. We've been working on creating basically hybrid models where there's a layer which is an agent-based model and a second layer which is some model like a large language model or reinforcement learning. So that's kind of what this is. And then, so where this lives is here is open source sustainability using large language models. This is the repository where we've had a lot of our pull requests. We actually have 2 open pull requests. I thought I had gotten them all. But we had, so 2 open pull requests right now. I'll take care of those later. But we have a lot of closed pull requests. And this is, like all sorts of stuff that are different types of updates to things, different types of functionality that have been added, and all of that. So this looks really good. And I had 1 or 2 conversations I wanted to highlight. So this is the list of closed pull requests. And again, we've had a lot. We had one which was the auto clear calculator that was fixed. We added a safety check. There was a routing and simulation scripts, dynamic issue creation. I think the conversation space for Slack-like interactions, which is good because we were doing things with GitHub and modeling GitHub issues. And so Slack interactions are a nice functionality there. Refactor issue reading logic, fix contributor assignment. There are syntax errors and import errors. This was in reference to, so issue 112 is in reference to issue 108 and 109. So it's this issue creation and conversation space. So there's people helping people. Then there's add engagement metric to conversation space, correct type initialization, and there's some other open pull requests that I'll look at later. This was issue 99. This is add requirements.txt for a large language model open source community dependencies. And this is where there was a requirements.txt file added where it makes installation straightforward. Currently, there is no requirements text in the repository, and this is just kind of a thing that makes it easier to use. And so it added a requirement.txt file, and that was to the front-end GUI. Okay, so that's for both Mac OS and Linux. All right, so this is just giving the detail on the pull requests. And then there was this conversation where we had someone pointing out, I think it was Akshat, that our requirements
Yeah,
text, what was that?
Yeah, it was me.
Okay, yeah.
Ravi, could you just zoom in a bit?
Yeah, let's see. So a requirements text already exists under open source sustainability. Instead of adding a second one, I think we should update clean the existing file. Having true requirements.txt files might be confusing. And this is updating the existing file. So this updated the PR to modify the requirements text instead of adding a new file. And so this is just adding the packages in. And then another thing that was flagged separately, and that was accepted. So that was, and then I guess I haven't checked the issues, but the issues, of course, there are issues that have been added as well regarding that and some other pull requests. This is another one here. This is where 112 was opened, and that resolved the syntax and import errors introduced by 108 and 109. So it's issues 108 and 109, or maybe pull requests 108 and 109. Yeah, the dynamic issue creation enablement was 108. So I guess it's issue 63, pull request number 108. And then that's this PR, which is 112, fixes to the enabling dynamic issue creation, which was 108, and adding conversation spaces simulate Slack-like interactions 109. So these are the syntax and import errors respectively. Syntax error in run, the run file, and then import error in the simulation file, sim.py. So then this is just kind of showing how to test. And then, yeah, this was, thanks for catching this. This was Hafiz -exe. And then this is just kind of like if you issue a pull request, sometimes, different types of inconsistencies are catched by the continuous integration. And sometimes it's not. If you look through the code, you'll notice maybe something. Or if you notice at runtime, you download it and do something at runtime, you'll notice it. So it's nice that people are catching these and helping each other to address the issues. So thank you everyone who contributed to the repository. The other thing I'd like to talk about is the DevoWorm meeting from this last week. So this was meeting number 9, and of course we do these on Mondays. We had Barshan Mandal. He presented on his project, which was incorporating attention into DevoGraph. So DevoGraph, we've been working on an approach that's basically we segment features out of microscopy data sets and other types of data sets. Then we build graph representations using those segmentations and maybe using some other data, where we create nodes, which are maybe like centroids of features, or it could be like other types of data that are entities. And then we build these edges that are relations of those entities or features, and we can build graphs that we can build regular networks. We can build hypergraphs, which are networks that are embedded in other networks. We can build other types of descriptive graphs. We've been talking a lot about tensegrity, for example, in the meetings, or we've been talking about other types of tissue morphogenesis. And then of course we have spatiotemporal graphs, which are where we, of course, the graphs as developmental things are embedded in space, but they're also embedded in time. So we want to look at the temporal graph learning that happens in which you would model in graph neural networks, but is actually something that we're interested in terms of development. So this is working with connectome data, which is like in the C. elegans nervous system, you have cells that are connected through different types of connections. We can characterize those connections from existing data. We can characterize the cells, but we want to model aspects of the connectome related to behavior and related to other sorts of activity. And so this is what Barshan is doing in this presentation. He's using this explainable spatiotemporal graph learning graph evolution learning approach, or SGEL, and this is where they're validating this in a neuroimaging data set, and it's showing how in that data set brain functional networks, which are usually the networks that they look at using fMRI, where they look at the activity of different pixels of brain tissue, and they look at the hemodynamic response. They can look at those networks as sort of proxies for what's happening in the connectome and the human connectome, but it's also looking at that over time, how it changes when you engage in cognition or you age or whatever. And so this is the neurodevelopmental cohort. This is where this method that he's proposing successfully modeled how brain function networks transition from dispersed to convergent modular structures during development. So it's like this increase in organization. And so then there are a bunch of baseline tests. So he's kind of talking about SGEL. And so this is like a method that people have used in like brain networks and things like that. And now he's kind of bringing this to the DevoGraph approach. And of course, in graph neural networks, that's a whole different field. If you're used to like large language models, or you're used to like reinforcement learning or just regular machine learning, it's very, very unique in a lot of the ways in which it deals with data and models data. And so they don't necessarily have an attention mechanism built into those types of algorithms. Usually you have, a graph representation, and then you have maybe message passing, which is like how you model things moving from node to node, information or flows. And then you have other types of symmetry processes and other types of processes to enable you to construct new graphs, to find all optimal graphs, etc. So it's very, very different from typical machine learning. So this is where he kind of wants to make this connection, not just with using something from the brain network literature, but also from the regular machine learning literature. So this is talking about the dynamic relation learning module, which uses a gating mechanism to fuse historical and current network states, ideally for modeling embryos where past cell divisions influence future structure. So he's kind of going through, like, kind of making this transition, this dynamic relation learning where it's capturing spatio-temporal dependencies. This is the proposed DevoGraph integration workflow, where he's saying that you have these developmental data on the left. You then have this dynamic graph construction from the data. You have this graph decomposition step, and then you have the dynamic learning step. You have this readout, and you get these two things, which is explainable dynamic graphs, and then predictive embeddings for cell fate and morphogenetic mapping. So, and then he did this visualization in Napari, which is a program that allows you to visualize high-dimensional data. This just shows like the lineage tree as it's moving, as it's being built. So that's interesting. Also, it's this other thing, the gaze graph. It's here. This is actually another thing that he talked about, which is really interesting technical detail. Okay, so then we had some discussion on this, and then Utkarsh Tyagi, he presented on his work. He's been presenting on this work that he's been doing. It's been a lot of different things, but I think it's focused on, what is it? I can't remember what the title of his little notebook is here, but he has this notebook he's been pulling out. And so he's thinking about building this model where you're incorporating chemical signaling, physical properties, of the embryo, biophysical properties in particular, and then modeling things like that. So he's showing this work that he's doing here. This just follows up on some things that we were talking about with respect to, what do we include in a model of biological complexity? So we can't include everything, but we don't want to make them so sparse so that they don't represent biology. And so that's always a challenge. So we're talking about that, and he was kind of addressing those points. And then these are diffusive spatial graphs. So this is a bottom-up approach, and then this is just kind of this general model type idea using a formal sort of framework. And again, he goes through some more of this stuff. Then he goes on to this. This is actually Shreyas, and he is talking about this these hyperbolic spaces for the connectome. So the idea is that the connectome is, you can model the connectome in a lot of different ways. Usually people model it as this sort of network that is just, it's a network. It's not really embedded too intimately into the anatomy. Usually it's like, okay, these cells are in these locations, but they don't build like a representation of that space. And so this is where he's talking about building a connectome and embedding it in a hyperbolic space. And the reason you might want to do that is because then it gives that graph some spatial relevance to the anatomy beyond just simply like location. It also allows you to do, implement ODEs or neural ODEs for applications to graphs and graph neural networks. So this is where he kind of thinks about the structure of the connectome, the hyperbolic embedding, and he was talking about these Poincare maps, which are like representations of the space, this sort of hyperbolic space. And so if you're given a discrete connectome, snapshots of a discrete connectome in time, the goal is to learn a continuous developmental model, which is stated here. The constraints are it must be graph-based, it must use hyperbolic space meaningfully, it must be biologically grounded, and it must interpolate between stages, because usually our data is sampled in stages. You get like measurements at specific times, and you get these static connectomes. And what we want something that is continuous. To do that, you have to do some interpolation. And that's why we're doing the interpolation, but also that interpolation benefits from the hyperbolic space. And so this is just talking about why hyperbolic spaces. Hyperbolic geometry naturally includes hierarchy and is similar to a geodesic. So if you're measuring a distance from neuron to neuron, if you're thinking about like communication between neurons, or you're thinking about like axon finding between neurons or whatever, usually you're not dealing with Euclidean distances, you're dealing with geodesics. So if you're measuring this 2 points on the surface of a sphere, you don't draw a straight line, or like a plane won't fly in a straight line, or it'll fly according to a geodesic, which is different, and you have to deal with the math, but it gives a better representation. So then he talks about hyperbolicity, and then there's this Poincare disk, which is where he embedded the connectome into this. Actually, it's the network where you have a degree of connectivity. So you see the highly connected nodes are in the center, the more weakly connected nodes are right on the edge. So that looks like an interesting result. And then thinking about radial hierarchy, which is what we're just looking at, and some more tests there. There's radial drift, which is where you have radial change and why you have radial change. And then some things that happen over development across stages. This is just showing the different stages, and then the idea is that instead of having this kind of jagged function here, we have a smooth continuous function, and we interpolate the events in between. So that was good stuff. And then we want to add graph neural networks or graph networks into this, where we can actually then capture some of the motifs and community effects and so forth. Okay, so that was all I had on what we did in the last week. I think that was pretty good. And then, of course, talking about GSOC proposals and everything. So yeah, get yours in as soon as you can. The deadline is the 31st. A lot of interesting stuff this year. Another thing Jesse mentioned in the Slack was there were some emails in the mentors thread or the mentors channel, which is like you get emails and a lot of emails sometimes, but it's always fun to look at what they're talking about across different orgs. One of the things this year was like people were using AI a lot to make submissions and pull requests, and it's like for some for some org heads, for some mentors, it's becoming a burden because there's so much content. And I don't know. Jesse asked me how I felt about it, and I was like, well, I don't know. I guess it's not horrible if it's not junk. You know what I mean? Like if people use it responsibly, or if people were actually putting in the effort to make a good faith project. And so yeah, it's a controversy, let's just say, within that group of people. So that's just I might talk about that later in more detail. Maybe another meeting. So I think Akshat wanted to present his things here today. And Sarrah's here because Sarrah is the mentor for this project that we're going to be looking at here. So would you like to share your screen?
Okay, so I'd like to start with a brief introduction. I am Akshat and I am an electronics engineer. Like I'm meant to be an electronics engineer. However, I have drifted a bit into AI and CS stuff because it honestly looks so interesting. And so I was looking through GSOC and found Oral Lab, and this project looked really interesting. So I've been contributing for past week now. So I'd like to, this is not my proposal by the way, I'd like to just talk about some issues that can be tackled before the proposal period actually starts. So the GSOC part actually is more focused rather than solving minor problems like these. So the current setup that was added yesterday, I think, it was added by Satya Kapadi, and he basically added a FIAS vector database which was updated every message, but that was too efficient. That was too inefficient. It was taking very long. So I pointed that it should be done in batches of like 3 to 5 messages. That way, the FIAS database doesn't have to be updated after every single message because it is not actually updating. It is just deleting the entire thing and then it is rewriting with that one extra message. So that system was very inefficient. So I thought about this, and I'd just like to talk a bit about the current setup we have. One contributor agent sends a message in the conversational space, then it will be registered as a message, and that message will then wait until the batch finishes of, I think it was 3, but until those 3 messages don't come, it just waits, and then it is embedded into files and then it is retrieved. So this had 2 major problems. First is that it doesn't actually simulate a conversation, which is the aim of the project. And second problem, I think, is the chat history and the Git history. They are not connected. We are basically making 2 different environments where there is only chatting occurring in one and Git things occurring in another. These 2 are not connected. Now, that is not how real developments work. In Slack, we generally link like I've sent this PR, I'm working on this issue. So I thought that is not what we are simulating. We are not doing that correctly. So here's my proposed context structure for the project. We basically have a message base where we will have sender, content, and whatever issues or PR it is trying to converse with. That way, we actually have context, so LLM knows what to answer, how to answer, what is being talked about essentially. And then we have a PR database which will have ID. Now, ID will act as the primary key to uniquely identify the PR or issue. Like we see in Git, we have issue number 108, we have issue number 68, PR this. So that way we can actually link Git and messages. Then the PR will have content, whatever it's trying to convey, and related lines of code. And I didn't actually think this hard enough, but I'm thinking we can also write lines of code in another part, which basically has pointers that this is the file we are talking about, this is where the related code starts, this is where the related code ends, and like that. So that way we are able to just send message, then we can add some logic to also fetch the context provided in the PR and issues and etc. That way AI is able to converse more efficiently. Now, anyone have any thoughts about this?
Yeah, hi Akshat. So when
Yeah.
you said the current scenario, did you mean something introduced by one of the recent PRs?
Yeah, it was introduced just yesterday, this part.
Yeah, right. Okay, so were you the one that introduced this, or was it somebody else's PR?
No, it was Satya, I think. I
Okay.
only reviewed it. It was I
Okay.
just told one correction. He did most of the
Yeah.
work. Yeah.
Okay, sure. Yeah, so I get your point. So the thing that you pointed out, right, that
Yes,
we need
yes.
to have a connection between the
Yes.
conversation space and the code space.
Yes.
So yeah, so I like this idea as well. What you can do is on the GitHub only, on the PR, you can suggest this, and then you can tell Satya, whoever it is that started the PR, that
Yeah.
you are working on this part, so that you don't have code conflicts. Because if he is trying to work on something else, that will
Yeah.
be an issue. So you can discuss with him, and maybe he will also have some ideas. So you can
Okay.
collaborate on the PR, and we'll keep reviewing that.
Okay. The PR is already made. I think I should open a new issue with this architecture
Yeah,
proposed.
sure.
Yeah.
Sure, you can do that. And you
Okay.
can also just tag the original contributor as well,
Okay.
and
Okay.
link
Sure.
the original PR.
Yeah. Okay.
Yeah.
So now I'm moving on to the second problem, the memory system. See, I'm now thinking that we humans have basically two types of memory, short term memory and long term memory. Short term memory is whatever occurred in 15 or so minutes ago, and long term memory is the memories we have ever since our childhood. So, now for short term memory, what I'm thinking is we have a sliding window like algorithm. This notes the last 5 messages we have sent, and these are provided to the agents whenever they try to take an action. Now, through this, we can actually simulate a conversation. For example, let's assume message n minus 1 was I am working on these issues. So then message n will be, yeah, and this issue can be tackled like this. This has these shortcomings and like that. And for long term memory, this is mostly implemented right now, I think. This updates every X messages and is used for only semantic searches. So, for example, someone's working on issue 51, which was very related to a previous issue 24, let's say. So, through long term memory, we can fetch the previous issue and whatever discussion related to it through vector databases. So I will also be sending this to the issues tab so people can start working on it. Okay. Now, the second main shortcoming of this project is the current agent calling. Now, in this, it is basically a for loop. Alice talks, then Bob talks, then Carol, Dave, and Eve. So this is very a robotic simulation of this. For example, let's say we are Bob. So then we can only respond after Alice says something, and only Carol can respond to what we are saying. So this is not a very good real simulation, right? So why this fails? Basically, if we graph the percentage of messages sent by one person, it is basically 20-20-20. Now, this is very robotic, so I'm suggesting a probabilistic selection here, that the probability of a contributor acting is calculated by the motivation of the contributor, and we can divide it by the motivation of all other contributors combined, so that we can actually get some realistic distribution of conversation. An agent who is more motivated will tend to talk more, like Alice and Carol here. And some agents who are less motivated, such as Eve, they will tend to talk less. We can have max this much responses per 10 contributor, so that one agent doesn't dominate the entire conversation, and it will become a monologue. That's not a conversation. And we can also add some limitations that no contributor shall speak twice in a row, because one agent will send something, then it will wait for someone else to respond. And motivation, I think, is already implemented. We just have to use it to simulate this entire simulation. So any thoughts on this approach?
So to be clear, the way it's implemented now is sort of a serial conversation.
Yes, it's
Okay.
a loop basically.
Yeah.
So Akshat, not about the recent PRs. I don't know if there's been any changes, but in the main, like in some time ago, there were two methods, right, in which it used to take. One was decentralized.
Authoritarian. Yes.
Yeah. So which one are you exactly talking about when you say it's serial? Do you have any example of it? Have you tried it?
Yes, I
Do
have
you have any
tried it.
screenshot?
I didn't prepare any screenshot, but I think I should have some enclosed PRs. Actually, this was very recently.
Okay,
I want to
you can
correct
just tell
one thing.
me. Sure, no worries.
I want
Yeah,
to, yeah. This is about the conversation that was recently implemented.
Okay, you're
not
talking about the conversation
Yes,
space, not the
yeah,
earlier conversation.
yeah,
Okay, sure.
yeah.
Okay, so you're basically suggesting a weighted.
Yes,
right?
yes,
Okay,
weighted.
sure.
So yeah, the Git one uses bidding and something.
Yeah, that's what I was coming to. That you can
Yeah,
maybe
yeah.
also take inspiration
No,
from those for. So as it, sorry, continue.
Yeah, the Git one is working very well. I agree with that approach. The bidding one,
Yeah.
we use the experience to weight the action probability. So we can also do the similar thing in this as well. But the conversation space is just like I told. It is like not very. This is not connected with the Git part. It's the
But you're
recent PRs.
suggesting we connected, right?
Yes.
Yes, okay. Another thing that I can suggest for weighted is I believe Vidhi has also worked last year on using weighted this in her project. So you can also have a look at that. And then you can finalize a formula and you can try to implement it.
Okay.
So your formula looks good. I'm just saying you can also do a little bit more research on how it has some real life impact. So you can find some kind of research that suggests how people speak in the real life. So, for example, you make a statement like, "We should introduce a limitation of no contributor speaking twice in a row." But sometimes that does happen realistically, right? So
Yes,
I'm
yes.
saying anything that you try to introduce as a limitation or as a formula, try to have some real life research that is backing that up. So, for example, that is why I brought up the authoritative and those models, because they are based on models that we have, observed that people fall into. So you can try to do some similar research for this and then try to come to the code and formula later.
Okay.
So as
Okay.
Bradley also said, yeah, it's more research based. So
Yes.
make sure to have something backing up all your,
Okay.
if you try to introduce a new formula.
Okay. Yeah, I'll look into some researches. This was like very primitive, like I was just
Yeah,
telling my
right.
idea.
Yeah, so it's a great idea.
Okay.
I'm just saying you can, before you start coding, try to look at it some more.
Yeah, yeah. Well,
Yeah.
I'll look into some research paper.
I'd like to add a little bit
Now,
about that too, is that, sometimes this is what conversations look like. Like having seen a lot of like conversations and teams and that, and sometimes there are people who are speaking more. I mean, like if you do for our Jitsi instance, I'll often look at like how much people have talked during the meeting, and it's like usually a couple people have talked to most of the time, and a lot of other people haven't really contributed very much, and that's a pattern that you get. And the question is that I mean, it's a real pattern, but is it desirable? And one of the things that we've tried to do through the history of this project is to simulate teams, open source teams,
yeah.
and say, can we improve upon our performance in teams? Can we model kind of realistic, scenarios? But then can we improve upon that, and how would that happen? So, having this distribution is nice because you can actually play with things in the code and modify how those conversations happen and see what the results are.
Yeah. Another thing that not specifically to you, Akshat, but advice in general. So I can see a lot of contributors trying to contribute for the conversation space. So one thing that I just wanted to put out there was the whole. So I mean, I love these contributions as they are like small pull requests as like kind of quick fixes. So we have a primitive idea of a conversation space, but when we actually start working in the project, in the timeline of GSOC, the main idea behind conversation space was similarly to how code space takes actual GitHub history. The whole idea behind conversation space wanted to be that it takes bit from organization's existing conversation, whether it is happening on Slack or whether it is happening on some other platform. It pulls that actual conversation, it pulls the actual contributors who are talking about it. The same way for Git, when we add the GitHub link, it takes that and then it goes through that. It takes the existing pull requests and then it works on making new ones. So the similar way for accurate simulation, what we want to do is take the existing data, take the existing contributors, analyze their behavior, and then simulate how they would act in the future. And so that is what. So this is a quite a complex. It requires integrations and it requires a lot of research. So I obviously do not expect this in current PRs, but this is something that I would really encourage anybody who's all the contributors who will even look at this video. I would encourage you to start thinking about it, because apart from just your current PRs, the main thing that you'll be working on in the coming few weeks is your proposal. And in your proposal, you would like to propose what ideas you have for the entirety of the project duration. So yeah, just a suggestion on how to start thinking about it from now itself.
Yeah, as I've also seen in the recent PRs, as Mr. Bradley mentioned, that LLMs are being used without understanding the code.
Yeah.
I think our repo is also suffering a bit from that.
Yeah. So yeah, I mean, so the PRs are obviously, it's an open source repository. PRs are accepted, and then as you know, as we also saw it happen, some PRs introduce some bugs, someone else points out those bugs. So that's where the whole collaboration aspect comes in. So that's fine. That's from an open source repository perspective, that's completely fine. But from a GSOC perspective, you do need to think a bit into the future and plan out your whole project.
Yes, we need to reduce the technical debt from every PR we commit to the project, so
Yeah.
that less maintainability. Okay, now this part will be going to my PR. I just wanted to discuss what is the current way, what is the best way to implement this entire model. Currently, we have a lot of steps. Git clone, then we go into CD, we install some things, we install the requirements, we install OLAMA, we get the Docker running, we make an image, then we have to run that every time we try to start the project. So this is only some food for thought, that we can also have basically a PyPI library, pip install LLMA with this project, and we can run it like UV icon if someone has used it. That we just type one command and it sets up itself on its own. So I'd like to write why should we use the pip. Firstly, it gives a lot of accessibility. We do not need a lot of setup and coding knowledge to start working or inferring data from the framework. But this will also have some drawbacks, which I am telling in this slide, that the pip package will need a lot of work. The current project we have is a lot closer to being a full-fledged repository, which is only targeting a niche amount of people who want to research how conversation works and how well we can simulate it. We can bring it a bit to more accessibility. However, this will need a lot of work. So we need to replace the ACR and Dockers with other alternatives, which may be light or doesn't need that much installation as we are doing currently in this project. And basically, allowing the pip installation will also attract more contributors, I think. Now, I haven't been much active in the open source space, but I believe making it more accessible will reduce the barrier for entry we have for contributors. They won't need to do through such tedious steps, and yeah, this way we can attract more contributors. But the way I think will be much harder than if we just let it be a lab. So that was So any thoughts on this proposal? This part will be going into my proposal. I think it's a good idea.
Yeah, it's definitely a great idea. It's definitely one of the things that we want to do to make it more accessible and more like a software that people actually use, not just contributors, but even people who want to use it in their day to day actually start using it. So that's one of the steps forward for sure. A pip library is also a very good idea. One of the things I would encourage you to start looking into is firstly, you are suggesting that we still install Olama manually and then run the pip package. And so that's absolutely fine because Olama does need to be on your local system. One thing that we need to look into is how will we have the configuration. So if we make it a pip library, apart from just making it, once it's installed, how will the user connect it to their local Olama? How will they bind that? Second thing you need
how
to
they will choose the model,
how they will how they will make sure the pip package runs their local Olama. There will be configuration steps there, so you can start looking into that. And secondly, you are I think suggesting that we don't have a local Docker image and we have something running on the cloud.
Some alternative.
So you can. So I'm sure there are Docker cloud alternatives where we can have an image hosted sort of. But you should start looking into that. If there are even also if you start looking into something hosted, if there are any costs associated, so you should find out that as well. And we should try to make it easiest as well as something that is the most cost effective way, because it is open source at the end of the day. So you can look into that and how all these configurations, like whether it is possible, and also if there are any alternatives to making it a pip library that make it easier to run with Docker and Olama. So you can look into that.
So, and about the cloud part, I was thinking that we can also have an option to run it locally, but we don't need as much setup as we need here. Like we can have a Python script to set that all up. So,
Docker image. Yeah. So you can look into that as well. So you can just start mapping out all your options and consolidating them.
Okay.
Yeah.
Okay. Thanks a lot. So,
Bradley, any thoughts? Sorry, Bradley, I thought you wanted to say something.
Yeah. So I had a technical question about this. So why do orgs use, or why do packages use pip install over like install, or what's the advantage there?
Most of the researchers and developers know Python the best, I believe, because it's an easily accessible language. And the current framework works entirely on Python. So that's why I wrote pip install. But I haven't actually mapped this up. I just wanted to collect thoughts that should I work in this direction.
Oh, well, yeah, I mean, I guess, it might be advantageous. Like you said, though, there's a trade-off between power users and casual users. So that's is pip for casual users more than for power users?
I believe so. Yeah, pip is very much more accessible than setting up all GitHub and Docker images and such all that. So pip does reduce it. We can also map it to an exe later on. I think that we just tap it and it works.
Yeah.
But first we will need to walk in steps. So I believe making it into a pip will be a huge step, and making it to an exe will be much easier, I think, because we can just directly convert the Python file into the exe file.
Yeah.
But this will require a lot of coding, so I'm a bit worried about on that front.
Yeah. Well, no, I think it's, eventually we'd like to have like different options for doing installs and things, but yeah, I mean, I'd have to do more. I just, because I'm just curious why people use pip versus
So Bradley, what's the technical answer to your question is the first way is what we use, cloning the whole repository and running it is what we use when you have intentions to contribute, when you have intentions to change the code and see the changes on your own, whereas pip is a packager. So it's one of the most widely used packages for Python. So what it does is it has like this sort of compiled code. You can't actually make changes to the code, but you can run it very effectively because it's already packaged. And there's of course other alternatives also. There's Poetry, there's UV that works directly, but pip is so as again mentioned by Akshat, because the whole project is already in Python and pip is also Python based, it would be a very easy transition to pip. But yeah, when users would use pip, they would just have the software running, they would not be able to change the code directly from the pip package.
Okay.
For that, they would have to go clone the repository.
Right. Yeah. It's that's something to think about. But I think that's probably like secondary to actually doing something with.
This steps comes after we do all these things.
Yeah, I mean, we don't really have a huge active user base, so I don't know how useful ultimately that would be.
Well, eventually making it to pip will help us expand the user base because it will become more accessible, as I told. So there will be more users, I believe. either way, this was my presentation. Thanks a lot for the opportunity to share my ideas.
Okay.
And
Yeah.
and I wanted to warn about one thing. There's the open source repository called Neutralo.js, I believe Neutralino.js, something like that. It had a very major security breach, I believe just yesterday or 2 days ago. One GitHub user was hacked and he wrote in some malicious code into the repository, thereby infecting very large base of the contributors. So I just wanted to give a heads up with this situation.
Yeah.
And
Thanks. Yeah, that's
yeah.
not unusual. Unfortunately, there are a lot of cases where sometimes if you get, there was one case where a maintainer was not paying
ZX,
attention and someone had
yeah,
put
the ZX incident.
yeah malicious code into
Yeah,
things, or so yeah, it happens
yeah, the
unfortunately more than we'd like.
Oh,
But
okay. Either way, thanks a lot for letting me present.
you're welcome. Yeah, thank you for that. Great work, ideas, things like that. All right. So yeah, thank you. Sarrah, did you have anything else to say, or?
Yeah, just very happy and excited to see all the recent activity on GitHub. I'm sorry I've been a bit busy the past week, so I could not go through everything. So I'll be doing that over the weekend. And yeah, to all the contributors, I think when we put this video up on YouTube, we can put it up in the GSOC channel as well, and encourage more of our contributors to join these meetings. So because apart from the PRs and the code, this is where we have the discussions, and these discussions is what will form the base of your proposals when you start writing them, which is quite an important part in the GSOC journey. So yeah, looking forward to having more contributors joining the meeting.
Yeah, very good. Thank you.
Thank you.
Yeah.
From my side.
All right. So yeah, I see that Morgan and Jesse are here. Yeah, hi Jesse. Hi Morgan. I don't know if either of you wanted to give an update or how you want to do that.
I can, speak briefly.
Yeah.
Hi everyone. I know I missed the earlier part of today's meeting, basically. So I don't know. I don't know if it was just all GSOC stuff until now, or what happened earlier today.
It's basically GSOC stuff. Yeah.
Yeah. A few folks have reached out to me, which I'll be getting back to. I'm in a similar situation as Sarrah. I'm just getting back from a lot of traveling and various events and some family stuff. So I'm kind of catching up on emails and some messages about this and other projects. It's a really interesting time. Most of my updates aren't GSOC related, but just pushing some things forward. There's been a lot of progress this year, and I haven't really had a lot of time to talk about some of those things. Kind of from the, just as a very brief overview without going into depth on anything. In terms of like old uh the old I'm gonna say old magic. In terms of much older ties that go back years and years, Frontier Map is being developed into some like working papers and beyond now, and sort of demarcating the different versions of what Frontier Map is. And it's nice because sort of it's related to um, it's not there hasn't really been a full release of, let's say, the JoPro Future Center, but as I'm developing that, a part of a suite of things that we're working on are basically frontier map, um, and a lot of these associated projects around like comprehending. One of them is sort of organization, like almost meta science or meta science and organizations of like the landscape of certain groups that are dealing in sort of what their schools of thoughts are about how fields are emerging. Let's say um, there's a project around um, um, for a long time. Bradley and I have had conversations around um, more how to encourage more synthetic time, either in academic conferences or at events or whatever. This sort of time where not just people come and point their, oh, here's my idea, here's what we're working on. That's great. Answer the questions and go on. But something that's integrative for the community, or and how things are spoken about. So part of that, there's a component to that I'm working on that's sort of around um, something along the lines of demarcating the problem space or demarcating the domain of the discussion or of what's being said in terms of, especially for like relevant for interdisciplinary discussion. Um, I'm being a little hesitant in how I word that because um, there's a working title for that. So Frontier Map, the landscape, the problem space project. Um, those are those are in development. Um, there's one or two more that you know um, have ties there. Uh, but Frontier Map is something all the way back from I think like 2019 or 2020 that's existed and hasn't really been materialized. But it's kind of forming. I think part of internally speaking, myself as in, I think part of what's helping it come out now is that there's sort of a suite of things, emerging together that are sort of presenting almost like an ecosystem of related tools or concepts, which is, you know, has some interesting overlaps too, uh, lo longer term Google Summer of Code projects too, but we'll get into that at some other time. Other very, 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 very quick things to try to mention, and maybe we'll go more in depth, maybe we won't, but just as a very brief, update from my vantage point. And for folks that don't know me, hi, I'm Jess. I'm, sort of a research coordinator here. I came in many years ago through Google Summer of Code. Um, I stayed with the program to develop some ideas, and then Bradley sort of let me um, make things like Cognition Futures, which is sort of a working group that has sort of crested a little bit over time. But it was an opportunity to have this project and have some project leadership and develop ideas and do really interesting research. We had like really nice um, journal clubs and meetings over time. So the opportunity to develop your ideas and develop as a researcher and develop as a scholar or whatever you want to do, that's been very good for me over the years. And I've since made other organizations and done things that are spin-offs and downstream of that. So I'm someone who has a lot of that kind of history and has come up through some of orthogonal lab that way. Um, I'm currently doing things with a group that I founded called JoPro, and another group that's doing some business and consulting and strategic stuff as well. Um, but for now, I will be another with Sarrah and others, a mentor for Google Summer of Code, and also if you have questions about um, some aspects of how orthogonal has worked or some context over the years of certain things or certain projects, I might be able to speak to that. So when I'm talking about things like Frontier Map, almost no one in this room will really know what that's about at much level of depth, and that's fine. You don't need to know that. Uh, that's why I kind of brought it up a little bit. I don't know, um, with the caution or sort of the way that I did. Um, so that's sort of some projects from that that area of things, sort of the I'm calling it really future center is sort of the um, home for most of those things. In a little bit more concrete terms, some updates from other related groups. Plot Twisters is still kicking and has done a lot over the last few months. Uh, I was also attended a um, a friend and colleague of mine who's doing something kind of similar. If Plot Twisters is sort of designed at around sort of creating an online game world that has deal with sort of um, self awareness or sort of not a therapy chatbot, but sort of um, uh, moving towards interactions and games and opportunities for a user to develop certain like intrapersonal skills or maybe things like emotional literacy adjacent or sort of kind of a basic uh, curriculum around certain intrapersonal and interpersonal uh, skills, let's say. I attended someone's thesis defense yesterday. Um, and they're doing her name is Mona, and she's actually done a lot of things in sort of the technology and ethics space, Mona Hamdi, but she was presenting at um, SCAD uh, for her master's work in um, I'm not sure what to call it quite. Um, I can't pull up the link very easily, but essentially, she's working with much more applied things in terms of uh, you know, actually it's about grieving or loss and making a similar kind of component to dealing with that or having someone reflect on that and then also building a lot of building a lot of agentic uh built she mentioned made her own card game of sorts, which is part of something in plot twisters. But then she's using a card game slash an agentic operation for that to facilitate having some of that experience of end of life palliative care things that are helping streamline that. So it's very interesting to see a different application of both um, games or cards as prompts to get kind of reflection or certain kind of interaction, which originally for Mona and also for Plotters was an actual like physical card game, and then taking that interaction that's sort of iterative and somehow internally reflective and even also community oriented and putting it into um, a potential technical application. So there's some interesting like back in the cognition future days, we talked about phenomenology. We talked about kind of getting into that second person or like not just first person subjective, but the intermediary, um, like one internal to external or internal to shared. So it's from that perspective of like phenomenology, cognition futures type stuff. It's very interesting to see these sort of dips into that space, and I'll leave it at that. Uh, there's a lot of things that are happening, and there's some Substack posts that are sort of drafted and should be written from the plot twisters perspective specifically. So that will come, and then finally, uh, oh, the Princeton Envision stuff too. Um, I will be posting a video from that. I wasn't able to attend in person, but I will be posting a video on essentially the original panel that I was attending was AI in education, and I'll have a commentary on AI in education. The rest of the panelists were mostly focused on like K through 12 education, and I have a little bit more experience in this area, the arena of sort of undergraduate and higher education type things, or college and graduate school and professional applications or whatnot. So that's cool. That will come also, and then finally, there's NICWIC, which will be in Albany this year, New York Celebration of Women in Computing. That's about to happen. That's almost already here. It's hard to believe it's basically a month away now. I'll post about that in Slack. Um, I'll drop the link in the chat just so people can understand if they want to. This is stuff that most people probably won't know about or be involved in, but I'm just mentioning that it's on the radar of things like this. And then finally, probably the most this is also cognition futures related, which is sort of ironic because I wasn't going to do much with that this year, but very briefly, I'll just go through this. Embodied intelligence. I wasn't even sure if I was going to submit to this, but I am, and I don't know how much I dropped some of this on you, Bradley, or not. But essentially, let me see if I can pull up what I'm going for. I came about my submission totally through working on a bunch of other stuff. But I'm going to submit it probably today. And where did it go? That's so strange to me. Okay. All right, that's the second one. Here we go. So my lofty title is going to be Navigation, Affordance Perception, and the Ethics of Comprehension, Common Currencies Between Spatial and Epistemic Intelligence, which is very, very, very lofty. But some of the key things that they're asking for this year are the common currencies, and also ethics. And I thought, why not try to take a swing at putting those together somehow? And that's what I'm gonna, it's a low barrier to entry, and it's a small talk here, but I think I'll get some very interesting feedback from the group. So more about that in the class in Slack. I think this will be a very interesting. Their masterclass stuff this year actually looks really interesting. I don't know how to best interact with that quite yet, or like to sign up for that specifically. But good for the Embodied Intelligence conference. Um, the they kind of stepped it up a little bit from the last few years in terms of what they seem to be offering, so that's cool. Um, there's a few other things, but I'll kind of pause there. I know more folks have joined, and I'm sure you have some things to say, Bradley. So any questions or comments I can speak to?
Yeah, that's great. Thank you, Jesse. Actually, we were just talking about the Embodied Intelligence Conference in the intro. So I don't know if you had if you could bring the agenda back up. It's kind of interesting. Yeah.
Let me share this again.
Yeah.
I think this works.
Yeah. So this is and so they have these master classes that are like, I guess people can give 5-minute presentations during the master class. Then they also have the master class itself. So the master classes, if you go down, you'll see that there are different ones. There's one on reservoir computing. There's one on embodied robotics. There's one that's like a conversation between Mike Levin and the main person who runs this conference. So let's see if I can find them. Fuyima Ida, who's talking with Michael Levin on like I guess on embodiment and things like that. They also have a number of plenary talks, panel talks. Yeah, this is
I'm trying to
interesting.
find the list of the master classes, but it's
Okay. Thank you, Vidhi. See you later. Yeah, this is. Well, that's the registration. In any case, I don't. Yeah, it's where it is, but anyways, yeah, this is. If you could post this link in the chat for this program, people might want to take a look at it. Yeah.
Yeah. Well, let's see. No, I don't like. Are you? Did you mention that you're submitting to this properly?
Yes.
Or are you not? I thought so.
I'm submitting a breakout session in a masterclass session.
Okay. And are you for masterclass? Is that where you're attending it yourself, or is that where you're
the presentation, as far as I'm aware?
Okay. Yeah. Okay. Cool. I know I've seen some things, but I haven't, especially this last week and a half. I've not seen everything at all.
Yeah.
So, let me know if I can do anything with that.
Yeah.
But I will. I know it's a very busy time for everything else, but I will attempt to send you my what I'm submitting, just so you can see it there. I it's really funny because I hadn't I really wasn't going to submit to this, but then something came up with like, okay, like this is something that I want to try to, because there's sort of a as folks may be aware of, sometimes you have to start. Here we go. Yeah, sometimes you have to start your idea out at a certain level, even though you know where you want to go with it.
Right.
So,
there we go.
What I'd like to do with it, and there's something that I can't quite talk about yet, but I'm going to allude to, is some of the meat of the presentation is sort of some of the things. What is the core I really want to get at is sort of these things, and a key theme and topic for me and many friends is sort of navigation and affordance, and sort of the navigation, affordance, and selecting alternatives, or the selection process itself, and like those, I'm looking at that from the angle of common currencies, and in this case, the ethics, because I find this to be kind of I'm really curious, and I don't even really even know what are the ethical questions which arise from AI, or from EI, excuse me. And I feel like that's I know there are some things in that space perhaps, but I feel like that's such a important, but also you could take that in so many different ways in terms of in so many different ways. And so I'm finding myself kind of like, oh yeah, I forgot this was a massive class proper.
Yeah.
Between those two as well. But I think an interesting lens going forward, and this kind of ties into this ties into also apologies for some folks looking at the JoPro website, which is still up, and even I think Sarrah asked something about the old JoPro, the old something about
Oral
the
website.
code. And this is one of the latest versions of Google Summer Code things is actually still here in one of the old parts, but the website's basically going through a bit of an update here. And that's the JoPro side. As far as the Weebly site, I'll deal with that, address that in Slack, because I don't quite know the answer to the specific question. But so put a pin in that for later. Part of where I'm going with the ethics of it is something we've been talking about in the DigiNest group, which is sort of about narrativity, emerging technologies, and agency, let's say. One of the things that we're kind of, I guess I can loosely say we're doing in the group is trying to attend a lot of these Advancing Humans in AI, AHA, Advancing Humans with AI group at MIT. They host very nicely bi-weekly lecture series. They range from really interesting things to like Google vendors selling and talking about how cool their AI curriculum is, to some in-house, like this week was basically an in-house, one of their in-house people just kind of saying all the stuff they're working on, which is cool. There's quite a range of things, but I really I'm a big fan of what they're doing because getting certain community development in the space is really important, and having people, the chats and the participants have grown in the last few months, and I'm really trying to encourage that to be, the forum, but doing a hard mode hackathon right now. They're doing a lot of really stuff that I really support. So check out the AHA group there. But where I'm going with this all the way back to the master classes and whatnot is I guess the ethical component is, I think there's a very particular interesting, where I'm going with all of this about the ethics of an embodiment and whatnot is, I think there's some very interesting principles that are going to carry from, and ethical questions from EI, but also the relationship to digital narratives and emerging story technologies, more so narratives and agency, more so how is technology influencing perhaps even our embodiment, and ethical questions about being able to select or perceive choices in that light. So I will stop with that. I'm sure I've said plenty for now. Did you want me to show any more about the conference, Bradley, or
I think that's it for now.
Okay.
I'm glad that you kind of brought that up, though, because well, we'll talk more about it later. And yeah,
there's a couple opportunities. One in particular that I'll reach out to you about probably in the next week that are, let's say, downstream of the Embodied Intelligence Conference that also fit kind of this broader embodied intelligence, and then some of the things I've alluded to that I'd like your opinions on. So I will probably message you about that in Slack this weekend.
Yeah, it sounds
That's
good.
okay.
Thank you. Yeah. All right. So thank you. That was great. It looks like we have some people here, some of our other repository contributors. We have Ritesh and Riya and Kavya. So would you like to introduce yourselves? You can unmute yourself and.
Just in the meanwhile, I realized I did not introduce myself. So I'll just give a short introduction. I'm Sarrah Bastawala. I joined Orel when I started contributing to the a sustainability project in 2024, and I mentored Vidhi when she took forward the sustainability project via reinforcement learning last year. And I am also a potential mentor for any projects we have for the sustainability this year. So yeah, hi, I have you. Bye.
Right.
Yeah, all the new contributors, as Bradley suggested, it would be great if you can just unmute and give a short introduction.
Yeah.
Hi, can you listen?
Yeah.
Yeah, so I had actually attended the last meet as well on Saturday, but it was an informal meeting, so I'll again reintroduce myself. So I'm Kavya Zala. I'm a second year computer science undergraduate from Vidhi, India. So I have actually gone through both the projects of ORL, that is the DevoWorm and sustainability, and I have also made contributions to both of them. And I have a background experience in agent-based modeling, particularly in Mesa, where I have contributed some examples, particularly in the lead-based architecture. And I was also researching about different other behavioral architectures for Mesa. I also have some other background experiences in AI agents, RAGs.
Okay.
So yeah.
Thank you. Yeah. Okay, go ahead, Riya.
Hi everyone, my name is Riya and I'm a recent computer science graduate from Developmental, and I've been looking to this oral, like I've been interested in the course, and particularly interested in the analytical modeling side, and I'm really like it has like
Ritesh, are you there? Oh, there you go.
Sarrah Ritesh Thakur. I'm final year student of computer science engineering. So I was solving the issues by the oral group related to open source sustainability using LLMs. I had solved some issues and also created some PR, and my experience is related to agentic AI. So this was all about time. Happy to contributing in oral.
Okay, thank you.
Yeah. Hi, welcome Ritesh. Thank you. I've also added some code reviews for your PRs, so just go through those. Thank you.
Sure, ma'am.
Okay, I'm gonna go through some readings now. I want to see. Well, we'll go through like 2 readings and we'll see what they foster. So this is a paper, and this is something that we've talked about in the group, kind of going way back to the things we were doing when we started doing Neuromatch, and they had talks from different people, and they had Stephen Grossberg. So Stephen Grossberg is known for adaptive resonance theory. So what he's doing in this paper here will be important in the formation of adaptive resonance theory. And as you can see, this is an unsupervised learning model that consists of a comparison field and a recognition field composed of neurons, a vigilance parameter, a threshold of recognition, and a reset module. So it is basically taking the biology of the visual system and the attentional system and merging it into this sort of neural network type structure. So he's computationalizing a lot of this in a connectionist structure, what we would call connectionism, but would later figure prominently in the development of neural networks. I always like to look back in time in terms of AI and see what people were doing way back when, because I think it's informative and instructive for what can be, what's possible, and kind of the roots of what we're doing now. So this is Stephen Grossberg from 1976. Yeah, Johann. Yeah, I remember Johann John talking about, and that was his advisor at Boston, or
Yes, and Johann, for those who Johann John is somewhat one of my, I guess I could say academic heroes. I really like what he did, and Johann has a kid now, so he's a little bit more focused on that than hosting intellectually stimulating reading groups and discussion groups around Grossberg-like material. I think he does like NeuroLogos was his blog, or I don't know if it's a Substack now, but Johann has a lot of great commentary on these type of things. So I'm reminiscing about the times when he would host a lot of really good discussions. And now that I'm in Boston here, I feel like he's kind of in a different stage of his life, so we're not like hanging out and talking about this stuff. But it's nice. I'm imagining him chiming in on all this Grossberg stuff. So we can go through the paper. I don't mean to interrupt that.
Yeah. So this is on the development of feature detectors in the visual cortex with applications to learning and reaction-diffusion systems. So it's worth thinking about the history of AI, where there are things that were going on very early that were, the attempt was to mimic biological intelligence, however that is. So if you go back to McCullough and Pitts, they were trying to build a biophysical model of neurons. And that's actually kind of what they proposed in their original papers. And so that was something that was the basis for the perceptron, which came later. And the perceptron is the idea that you have this machine that does perception. And it's always this metaphor followed up by some abstraction of the biological system. And of course we lose in that abstraction, we lose detail, and we lose the things that maybe make that thing quote unquote biological. We lose the complexity to do things that are computationally tractable. So we want to model, say for example, a simple perceptual system, or we want to model some neurons and their connections, or we want to model feature detection and surround inhibition, things like that. We use some sort of computational abstraction, and we lose detail, but we keep the metaphor and say this is learning, because it actually does learn things. It has this sort of loose connection with biology, and it's worth thinking about because we do this again and again in the history of AI. And not to give a preview of what I'm going to talk about it, embodied intelligence, but this is one thing that we've never really resolved from the early years of AI. It's kind of like this thing that's stuck around with us. And the question is, will we ever kind of get past that and maybe to actual sort of biophysical machines? And the answer is, people have proposed that actually, and it never really went anywhere. We might be able to get there with things like organoids, like we've talked about, but still, it's maybe far off and maybe will never happen. So this is actually a paper that is, kind of the basis for a lot of the stuff he would do with neural networks later. So that's just giving some context here. So the abstract reads, developmental mechanisms for tuning the visual cortex. So his interest actually is in development, not in neural networks, in biological development. And he's interested in the development of the brain specifically. And so this is where we have the tuning of visual cortex. And this is, of course, where in development, if we're looking at the mammalian brain, we have a visual system that's starting to form. We have eyes that are opening up to the world, taking in light, and it's wired to this, set of cortical structures that need to be shaped by those stimuli. And of course, we can look at the neuroscience literature to see what happens when you have blind mammals that are, we have blind mammals. What they'll do is in an experiment that will nucleate the embryo, they'll take out the eyes, and then they'll just kind of it's like a rat or something, and then they'll let it live, into development, and then look at the brain structures, and they're very different from the brain structures of animals that develop a visual system and actually experience perception. visual perception. So, this is something that is interesting from a learning perspective because it suggests that while there are some things that are innate, there's a lot of stuff that's acquired from the environment, a lot of stuff that's shaped by learning. So, he's talking about this tuning of visual cortex, where visual cortex, the connectivity and the sensitivity of the cells and the regions are tuned by environmental mechanisms that are experienced in development. And so he's talking about this tuning, this adaptation, and that it's actually derived from adult learning mechanisms. So this is all defined as an adaptational property of shunting on-center, off-surround networks that prevents saturation of parallel processed patterns at high input intensities, a contrast enhancement in short-term memory mechanism, and plastic synaptic strengths that compute a time average of presynaptic signals and postsynaptic activities and multiplicatively gate signals. The mechanisms can generate fields of feature detectors, which are line or picture detectors. So if you're familiar with attention mechanisms, you know that people focus on this very thing, where you have this feature detection and you focus on the features and you ignore other things in the image. This is kind of where this comes from. And actually, this is where biological attention comes from, is this idea that, you're doing early feature detection in the visual system. And that's sort of setting up your ability to attend to certain things in a scene versus not attend to certain things in a scene. A developing hierarchy of such fields can be synthesized in which successive critical developmental periods are triggered as a dynamic equilibrium, as a dynamic equilibrium is established between short-term memory and long-term memory at each stage. So he gets into this critical periods work, this critical developmental periods work, and it kind of gives you this sort of way of approaching development and way of approaching developmental sensitivities and developmental tuning. So critical periods are these short windows in development where a lot of these sort of the most important things are acquired. So a lot of times in development we have structures that start to form and they exhibit plasticity at a certain point in time, like maybe a couple days of development. And if things don't happen during that couple of days of development, they won't ever happen. So you can have no exposure to the environment over those several days, and it can result in long-term deficits to the organism. Or you can have enhanced, enriched experience during those few days, and it can result in a positive thing for the organism. And you can use these critical periods to sort of look at how how contingent development is. In other words, if something happens during the critical period, it's acquired. If it doesn't, it's not acquired. And that sets up the sort of the complexity of the brain afterwards. So it's a really interesting tool to use to look at artificial intelligence. Then shunting adaptation can account for some data on spatial frequency adaptation. Shunting network properties resemble properties of certain reaction-diffusion systems that have been used to model developmental data in various species, such as Hydra, Xenopus retina, slime molds, and others. So this is where they're looking at these, they're looking at reaction-diffusion systems in development, or they're looking at reaction-diffusion systems, and they're looking at how those operate through the dynamics, and they're using it to model developmental data in these different systems where they're looking at adaptation and perception. So reaction diffusion systems are systems where you have maybe like a bunch of molecules in a chamber, and you're looking at how they respond, like different chemicals respond to pure diffusion processes. That means where they expand outward from a central source. So a lot of times you'll have chemical systems where you have diffusion of of a chemical signal or a chemical set of molecules from a source. And if you have a bunch of these operating in an environment, those sources will sort of have this area of influence or this gradient that expands outward, and then those gradients intersect and start to form boundaries. So this is actually a nice system for looking at pattern recognition, because you can model reaction diffusion as a system of patterns that form from sort of randomness or from, this sort of self-organizational property. And of course, back then the language wasn't quite the same as what we're using later. So this is, we use reaction diffusion now, but thinking about this sort of, these aspects of cognition and these aspects of artificial intelligence, the terminology wasn't there yet. So, for example, positional information due to regulation in reaction diffusion systems is analogous to constancies due to network adaptation. Firing of a developmental gradient is analogous to contrast enhancement, and maintenance of a pattern in morphogens is analogous to short-term memory. So if you're not familiar with developmental biology, this is a lot of jargon, but what it basically means is he's taking components of developmental systems and he's using this as an analogy for cognition. So you have this pattern that is a pattern of these molecules that's analogous to a store in short-term memory. There's a developmental gradient or the firing of a developmental gradient is analogous to contrast enhancement in the visual system. And then this positional information, which is where cells know kind of where they need to be on an anatomical axis in embryogenesis when an embryo is forming. And this also shows up in reaction diffusion systems, is analogous to these network adaptation mechanisms. So very interesting stuff. And he cites a lot of this early computational neuroscience literature. So he says 2 recent theoretical papers, and remember this is in 1975, so 1973, 1974 era. 2 recent theoretical papers discuss the development of specificity in primate visual cortex. Both papers use analogous mechanisms that derive their results. One of these mechanisms, which is plasticity of cross-correlational synapses, has been mathematically proved capable of learning arbitrary acts in a wide variety of circumstances. A second mechanism, which is on-center off-surround anatomy, is believed to exist in the adult sensory processing areas such as retina and neocortex. And this is in mammals. A third mechanism, attenuation of small signals in a recurrent network, has been shown to be necessary to prevent amplification of noise in networks capable of short-term memory. Then a fourth mechanism, conservation of total synaptic strength at each cell, can be replaced as an adaptational property of on-center, off-surround networks undergoing shunting interactions. So this paper argues that the formal mechanisms which have been suggested for the development of specificity are also mechanisms that are needed for efficient learning in the mature organism. So this is where you have this analogy between what's going on in development, what's going on in terms of how development takes us from this undifferentiated set of cells to organs and to structures and to other types of things that are highly asymmetrical and highly specialized, specificity, to sort of the same mechanisms that are used in learning and efficient learning. And so your learning, of course, is the encoding of information, the acquisition and retention of information, and the recall of information as memory. And learning, of course, is important in neural networks. He's not talking about that so much here, but this is something that is going to become relevant later on when he starts to work with neural networks and these other things that he's going to be doing later. So, and so this is where he cites Wiesel and Hubel, where they demonstrate that abnormal early visual experiences can induce abnormal development of afferent connections of visual cortex. In other words, if you don't have that early visual experience, you don't have the circuitry for later visual performance, visual perception, and that affects the rest of the organism's life. So that early experience sets the gain for later on in development and in adulthood. And so this is kind of what we see with learning. If you don't acquire things in training, you can't make good predictions, and so forth. And then they kind of talk about these other types of analogies between development and learning and how those things are related, and looking really at the structure of these different types of systems in biology and then abstracting that to computation. Not quite at computation yet in this paper, but he's starting to do some of this stuff where he's just drawing diagrams. This is reminiscent of what Breitenberg was doing in his bio-cybernetics, where he was drawing diagrams of circuits, and then that would later become sort of computationalized as this sort of, as you could build an artificial system with them. And then, this kind of goes through some of this other work. He gives a review of developmental network models. And so this is just kind of going over some of these models. This is looking at cortex and the orientation of cells in cortex. So one of the things that happens in development in the visual cortex is the cells become tuned to stimuli. And so this is where they're kind of looking at the neurophysiology here, where they're looking at the tuning of these cells to when the organism is orienting itself to a visual signal. And this is where they're teaching the visual system through experience how to, acquire this sort of tuning. So you can see here the view onto cortex after 100 steps of learning. It's figure 3, where you see these patterns of orientation that are sort of forming order, as opposed to being completely random. If you had an organism without eyes, you would try to do 100 steps of learning, or if it didn't have eyes during its critical period, but then it had the ability to acquire visual stimuli, this array after 100 steps of learning would be totally random. That's the idea. So these developmental mechanisms kind of map to learning and how things are learned, because development has, in organisms, development is sort of a precursor to learning. B, it uses similar cellular and molecular mechanisms, which isn't cited here, but this is something that we find out later in the 80s and 90s especially. And then C, we can use this metaphor for kind of neural networks and AI, but this is something where we had mastered the learning or gotten really good at the learning, but not necessarily at the development. So we have machines that can learn, but then development is still this thing that's like we're trying to do, and it's hard to kind of bootstrap learning from nothing. It's kind of like easy to build a machine that learns, like a neural network that acquires information and encodes it in these memory structures, but it's hard to sort of get something to form, sort of self-organize into a memory. And then do you rely heavily on innate features, or do you rely heavily on environmental features? That's where I think the problem is with the sort of developmental AI, is that we don't have that mix in a way that's that can give us good results. So this is just kind of going through some of the visual perception work, and he talks about recurrent networks and contrast enhancement, short-term memory, and looking at recurrent onset or off-surround interactions, and other things like that. And then he talks about developmental hierarchies and critical periods here. So another important property of the model is it can be used to generate a hierarchy of selectively tuned networks. This is like in visual cortices 17, 18, and 19, where there exist cells exhibiting ever more selective response criteria. So this is a hierarchical property that follows from the fact that the cortex in our model also adapts to its total activity, as section 5 describes. Hence, the cortex can be used as the retina for a second stage in the hierarchy. Its outputs will be the inputs in the next cortical structure, and its axons will also possess cross-correlational synapses. A central problem for such a model is, how are the critical periods of developmental plasticity in successive anatomical levels regulated so that the coded meaning of outputs from one stage to the next does not change from moment to moment? So in other words, how do you keep this plasticity? How do you lock in the adaptive results of this plasticity? You know, if you have a plasticity mechanism, things could just drift continually and end up at a place that's not optimized, or not even something that's learned. So you could just keep adapting, changing constantly, and never like lock in on the solution. And so that's what he's talking about here. Why is it that biological systems lock in on that solution and not just kind of change until a certain point and then stop, and then you end up with something that actually doesn't learn anything? So that, and it goes through this whole idea of critical periods and other types of things. And this is something that is interesting because this is something he's talking about in 1975. And he later goes on to do stuff with neural networks and all these other things and cognitive science. And as far as I know, this has never really been definitively solved. So this is kind of a thing that, you know, you bring up and then it's like a challenge and it's hard to kind of define how to implement this computationally or computationalize it. And then eventually we end up with, he did a lot of great work in his career, but it's like, you know, we still have things that are outstanding from this. So it's really kind of unlocking this huge problem space that we are still working on today. Okay, so that was the Grossberg paper. Okay, so this is, DevAI, hashtag. Ever more selective response criterion, section 6. How are critical periods of development regulated? Yeah.
Those are. I'll have to go back. Could you list the or mention the title of the paper again? Because I don't know. I want to look at that for other things.
Yeah.
So.
This is on the development of feature detectors in the visual cortex with applications to learning and reaction-diffusion systems.
All right, thank you.
And if you're, like, I don't know what your library access is, but this is a deep cut, as they say. Yeah, it's a very early Stephen Grossman paper. The reason I'm looking at this is, again, I'm not going to preview the stuff I'm doing for embodied intelligence. This is one of the papers I was using.
Cool.
Yeah.
No, I appreciate that. I haven't. It's funny for me because I'm like, I was alluding with a little bit of context. I don't know how useful be for people here, but in lab context in general, around whenever the augmentation lab summit was last year, which I think is sort of the summertime or end of summer, September or something, or August, I kind of from that point until the last few months, Cognition-Fusions in particular, kind of it was on a different kind of a back burner, and now it's like, but I kept saying to Bradley on the side, like, you know, there's stuff happening here, like even some echolopto stuff. I don't know if Morgan's still here or not, but you know, Addy and Echolopto crew, and then Elon with his LLM stuff, and Will Hahn with he's doing a lot with like music or the nature of information, different ways. Like, there's a lot of cool stuff there, but I was like, oh, you know, it's like Cognition-Futures were like, I was really high on that a couple of years ago, and now I'm kind of, oh, But now it's like there's this nice other resurgence of a reblending of things and mixing of things. So it's very cool to see this, and I think I don't know. I guess is the actual event proper? Like when is the the date? Yeah, the embodied intelligence conference is 18th,
19th and
So-
20th, I think. Yeah.
Yeah. So we'll have another meeting. So maybe something we could do for next time is obviously Google Summer of Code is sort of our broader priority, but maybe we can have a little planned session next time that's like embodied intelligence focus or something.
Yeah, that would be good.
And you're not going to spoil your stuff, but we could maybe have something. I'll try to prepare something with that in mind for next week. If that's what you want to do.
Yeah, I think so. We could have a parallel thing for our lab, like we used to do. We used to do these kind of run when people were doing a lot of virtual conferences, have these parallel sessions. And so and again, if you want to publish your talk on the lab YouTube channel, I can put that up.
Yeah. Sounds good. Oh wait, do you know? I haven't thought about this. Do you know if this year the talks are going to be live or pre-recorded?
I think live.
I think they're live, but then I remember a couple of times I did them pre-recorded or something like that.
Yeah,
doesn't matter.
Yeah, I think they're live. Yeah, like you go into
Okay.
the Zoom room and you.
All right, I'll say more about that in Slack. I'm sure you have other things you want to get to.
Yeah, well, I did want to get to one more paper, and I won't spend a lot of time on this, but I thought it was really interesting. Okay, this is actually a question from Kavya. Since developmental stages are triggered by equilibrium from short-term and long-term memory, what happens if equilibrium is disturbed by abnormal sensory input or chemical imbalance? So this is where we get into disrupting critical periods. And there's been a lot of work in molecular biology in disrupting critical periods. So you can open the window longer or shorten it up, or you can do experiments in neuroanatomy where you can take out the eyes of an embryonic rat and you can have it experience the world as a blind rat and then look at the brain, look at the visual cortex. And that's where your developmental stage is disrupted in some way. And that's actually where, and of course, short-term and long-term memory are affected there because you're affecting the sensory inputs, you're affecting the ability to learn and that sort of thing. You have more or less exposure. And so that's when you get this disruption and you get a lot of dysfunctions. You get sometimes if you don't get enough experience in the critical period, you end up with impairments or deficits in blind organisms. Sometimes those areas of cortex go unused. They don't get wired. They become smaller. They become innervated with connections from other senses. So if you remove vision, you end up with inputs from the proprioceptive system and the auditory system. So you can actually enhance your auditory learning by having no visual system. And that can be, recruited for consolidating memory, auditory memory, instead of for visual memory. So there are a lot of things that can happen if you disrupt that equilibrium. And then in artificial systems, you could use that to do a lot of interesting things. I don't know. You could enhance performance. You could degrade performance. You could do that with something interesting in multimodal models there. I don't know. But that's good. Yeah, it's good insight. So let me go to this other paper. So we talked about this idea in Cognition Futures a couple of years ago. This came up a lot. And I know Hussein is kind of interested in this. And this was also something that we talked about with Amanda and in the Cognition Futures group. This is a paper where there's this thing called the Bouba-Kiki effect. And it's where you present different shapes. You have like a shape that doesn't really have a name. Like it's an abstract shape. It's made of a complex geometric structure. No one's really been able to categorize because they've created this made up thing. It's like a spiky little ball or something, And people will give names to those objects based on their sort of shape and their visual properties. So Bouba is like something that's rounded and soft, and then Kiki is something that's spiky and sharp. And this is a cross-modal association, like we're talking about. So that means that if you see some object that has a certain look to it, you make a certain noise that describes it, and it sounds like what it looks like. You could also describe different sounds by their sharpness or softness in the same way. We'll describe sounds in ways that we'll have like shortcuts to naming things that are kind of we've never heard it before. We describe it. It sounds like and then you might say it's a Kiki sound or a Bouba sound or something like that. And those aren't like language. Those aren't words that we've used in language. I mean, they're not formal descriptions, but they're names that we ascribe to something that doesn't really have a name, and we just kind of describe it as, well, it's an interesting cognitive kind of curiosity. And so what's interesting is that people thought that this was something humans did because we had language, spoken language, and that was hallmark of human cognition. In this paper, what they're saying is that naive baby chicks, in other words, baby chicks, in a developmental stage, acquiring information, do something similar. So yeah, this is matching sounds to shapes, evidence of the Bouba-Kiki effect in naive baby chicks. And so the abstract here is, if you hear the non-words Kiki and Boba, you may be more likely to associate them with a spiky and round object, respectively, rather than the opposite. So Kiki is spiky, Boba is round, and it's just like kind of attaching a sound to what a shape might look like. Boba being round, Kiki being spiky. You might have like a waveform in your mind when you look at the object, and you might use that waveform to form the sound or something. This is a case of sound symbolism known as the Bouba-Kiki effect. Studies on 4-month infants suggest that this effect might constitute a predisposed perceptual mechanism. So this is in humans where they've looked at infants that do this, and they have this. So the idea is that it's some sort of innate effect that is innate to our perception as humans, and that it's something that we do early in development, but it is something that is also gives us like a tool to deal with information we've never seen before. However, these studies suffered from the impossibility of ruling out a fast experience-driven origin of the effect, resulting from infant speed of learning, their sensitivity to environmental regularities, and the large number of sound symbolic associations to which they are precociously exposed to when interacting with adults. In other words, it's very hard to do these developmental experiments. Are the babies simply just copying what adults are doing, and what the adults are doing has been learned from somewhere else? Or are they just kind of integrating information from the larger world and then kind of inferencing from that? We don't really know. It's hard to do these kind of developmental experiments where you isolate something to an innate effect. So to better describe its ontogeny and fill in this gap, and ontogeny just means its developmental course, we tested the Bouba-Kiki effect in domesticated chicks and Gallus. So these are chickens. Being a precocial species, chicks can be tested on the very early days of life, allowing for virtually total control of the experience before the test. So this is where you know that they haven't been exposed to anything in the world. Everything that they're doing is going to be somewhat, at least mostly, innate. And that's, kind of the idea in these kinds of experiments. 3-day-old chicks, 42 of them, first learned to circumnavigate a panel to obtain a food reward. Then they were presented with 2 identical panels, one depicting a spiky shape and one depicting a round shape. And then they hear the sound of Bouba-Kiki. All right. So they hear the sound, they see the shape, they're integrating those 2 modalities. We recorded which panel chicks chose with either sound, so they peck at the thing that they've chosen in a total of 24 trials. Chicks prefer the panel with the spiky shape when hearing the Kiki sound, and that with the round shape when hearing the Bouba sound. So we can assume that they're making the same kind of judgment or using the same kind of mechanism that human infants do. Results from naive baby chicks hinted a predisposed mechanism for matching the 2 dimensions of shape and sound that may be widespread across species. We talked about this with, there are a lot of multimodal models of artificial intelligence, a lot of multimodal models where you're training a model with 2 different modalities. And, this is important in large language models because large language models, we're using language, we're building models of language. We also have images that we can attach to those linguistic tokens. We can attach labels to images, and we can use that as kind of a multimodal learning system. So it's important to kind of think about what is possible, what's learned, and maybe what we can hard code into these models, and what we maybe need to hard code that can't necessarily be learned from data directly. Okay, so this just kind of goes over this history. This goes back to 1947, where they would invent these non-words that were kind of descriptions of a shape. You might look at the shape and look at the waveform of the shape, and then look at the waveform of a sound and make that connection. So maybe in the brains of these chicks or these humans, they're making this assessment of the waveform at both, and if it's similar, then there's a cross-modal fusion there. So there's a lot of work on cross-modal attention, cross-modal perception, where there's this idea that percepts fuse together for vision, for auditory stimuli. And when they're not fused together, when you don't have the visual information and the auditory information, say, the percept is weaker. So in other words, it's better that you have both modalities because there's a stronger response in different areas of the brain that enhance learning, that enhance memory, and that enhance sort of recognition later. So this is kind of the what they go through on this. And so basically, they have made this quite an interesting finding. And people originally thought that this was something limited to humans, and we find that this isn't necessarily the case. It might be a controversial experiment. You might argue with the methodology. You might argue that they're 2 different things. That maybe they're just kind of responding to there may be 2 different mechanisms involved. But this is something that, again, it's interesting. So the discussion talks about how the present study tested baby naive domestic chickens for an example of sound symbolism, namely the Bouba-Kiki effect, and they want to understand the ontogenetic origin of this effect. In fact, even if this is a strong and well-tested effect in our species, in both adults and infants, there is still an active debate on how it originates. We report a spontaneous tendency to match a round and spiky shape to the Bouba and Kiki sounds respectively in 3-day-old chicks. Our results fit into the current debate suggesting that sound symbolism belongs to a set of predisposed associations built into different species. Our data well support the existence of an early available mechanism as we hatched the eggs in the lab, where we exerted a virtually full control of the chick's experience, overcoming one of the biggest limitations from studies on human infants. Even though our subjects had never experienced the sound symbolic matching prior to test, they still spontaneously associated the two dimensions of shape and sound. This indicates that this Bouba-Kiki effect may take place in the earliest stages of life without the need of subject directly experiencing the cross-modal matching. So they don't experience cross-modal matching before this, that just happens. Similar results were obtained for other instances of cross-modal associations in this species, such as visuospatial, visuotactile, and pointing towards a predisposed general mechanism for cross-modal associations. So cross-modal associations are maybe thought to be innate, that you can build in those associations, or that they're sort of come as a natural feature selection mechanism. So this is really interesting. So yeah, I think I'll stop there on that paper. Yeah, I thought that was interesting in light of some of the stuff we talked about a while back in cognition features.
Yes, if I could more accurately represent what we talked a little bit about Elon Baron-Holtz's work and the LLM and language stuff. There's something to be said there that I don't fully grasp his work yet, but I think it would be an interesting thing to bring into that discussion. So maybe some other time, or if there's ever an overlap. We talked a little bit about an overlap between like Echolopto crew and cognition futures type stuff in the future. That might happen this year. I don't know. But absolutely, in terms of the, I don't know, what was it? Ontogenetic
Yes.
Meaning and things like that. That's still a key thing to think about, and also like an approach of it gets, you know, in the interest of time, I'll just very quickly say like that the ontogenetic development part, and then my current interest on the let's say ethics, which I'm curious, you know, I'm interested in how I'm going to deal with the ethics component, but I think in an applied sense, sort of selection, choice, agency, and how those things affect development as well is a very interesting space to look at. So maybe we can talk more about that next time. But thank you for the paper today.
All right.
And thanks everyone for showing up.
Yeah. Yeah.
Maybe your first time here, but we encourage you to continue to show up and interact in Slack and ask us questions and things like that too.
Yeah. Yeah. Thank you. Thank you everyone for your contributions and your activities over the week, and see everyone next week.
Take care, everyone.
Thank you. Take care.
Bye.
Bye.